All right, now I need to see blue stickers if you did the clone, orange stickers if you're behind. Kevin, can you help Joseph go around people that have orange stickers? To do the git clone? Yeah, I'm gonna put it here on the screen again. So what you have to do is this command. You open up a terminal. By the way, that's the reason why you use the NGT puller for tutorials, because it's much simpler. However, you have to know how to do that to actually take these notebooks home with you. Yes. The .kit? No, you don't need that, but it works. Yeah. I'm going to post the URL on Slack so you can actually copy. Yeah, I'm going back in a second. I'm just trying something here. Okay, I've seen a lot of blue stickers, very few orange stickers, so I'm gonna move ahead slowly, but if you're falling behind, just wait and one of the helpers will help you get that clone. So if you click on your tab, now you have all the notebooks here, and you can open the first one. However, because I'm cheating, I have the answers for all the exercises. I'm not going to use Pangeo. I'm actually going to use my local version of that notebook. Okay. So who here remember what the line means? And you get an extra sticker if you answer it to me. The first line. It's the inline backend, makes your plotting line. You get an extra sticker. So we need some data, right, to plot first. We're going to use the same data that we've been using before from the ODAP server. We're trying to search for a glider. I'm not going to waste all of our time explaining this again, but if you have any doubt about it, please come see me later. We have a small region and a time frame and a trajectory type. So we are trying to reduce the scope of the number of gliders that are available there. We kind of found 16 gliders. Someone brought to my attention that it was really slow to download all the 16 gliders today. I don't know why. Yesterday was very fast. We actually have another server that's faster. I'm going to update the notebook later. However, what I did here, I just hacked and I'm getting only one glider for the exercises because we don't really need all of those. Okay. So I decided I list all the variables that I want. I pretty much use the same constraint from the search to get the data. Create a small function to download it. We don't really have to do this anymore. We have that toPandas method. The only reason I did this is because the toPandas method get a header with the actual units for the data, and that's great. However, all my notebooks here are written with the column names like temperature instead of temperature Celsius. So I was lazy. Instead of changing my notebook, I actually downloaded it in a different way. Bad professor, I know, sorry. I will fix the notebook later and upload a better version for you. So this cell here is actually commented out, and this downloads all the 16 notebooks. I'm gonna leave that as an exercise for you later. So right now we got one notebook, and we're pretty much gonna go all those libraries that I mentioned yesterday and try to do the same kind of plots. So the first library is Altair. Who here heard about Altair before? Only a few, yeah. It's actually developed here at UW, if I'm not mistaken, and it wraps Vega and Vega Lite, which is an opinionated D3 which is a JavaScript library. So it's an opinionated way of formatting your data and creating graphs from that. It's completely different from Matplotlib. Matplotlib is imperative. Altair is declarative. What does that mean? For example, here I'm loading Altair, I'm selecting my glider, and I'm selecting just one cast from that glider. When I start my Altair object, my chart, for example, I have to declare that I want a point as a marker, and I have to declare what's X and what's Y. And I have to rerun this. Sorry. So Altair has a JavaScript backend to show the graph. And as you can see, even though I had run it before, because I closed and opened the notebook again, the JavaScript was not there. It's a safety feature from Jupyter. So I'm sorry, it's gonna take a while for it to load again. Once it takes a while, I actually have a new joke for the Spanish speakers in the room. Who is a better mathematician than R2? R3, sorry, R3. Yes. Joe changed the image yesterday, and I'm afraid he might have removed the Vega library. So you're probably gonna have to cold install it. You can do something like this. Let me see. If you open this cell, and you can try this, conda install Vega. I'm also not seeing any output here, and that's weird. Sorry.
Joseph, if we're ever on Pangeo and there's a library that we have,
you can do that. And there is a yes, you can. However, it may go away once you finish your Pangeo instance and start it back on again. And also mind this: you need to restart your kernel after your package is installed. I don't need to restart mine because I already had it. So I'm just gonna leave this cell here. But, and I promise this was working a second ago, I'm not having any graph as well. The data is there. So last year, we actually had the Altair here presenting this, and he used Colab, which has all this JavaScript pre-installed and all set up for you. We always have trouble setting up Altair on our local machines or on a cluster. And I promise you, this was working 5 minutes ago. So we're gonna skip Altair. The documentation is great though. You can definitely go there and check it out. So I'm gonna go to the next declarative option. By the way, all these libraries, they're pretty new. So they're actually stabilizing right now, so we can actually use them. This whole stack here is called the Holoville stack. All these packages are reaching version 1.0 now. So they're pretty mature to use. Altair should be mature as well. I'm sorry about that. I'm definitely gonna take that up with the authors and see if we can make it better. Something, maybe we have to activate a JavaScript backend or something. I'll let you know as soon as I found out. Like for this one, for example, we actually have to run this to activate the JavaScript backend, and it just works. So here what I'm doing, I'm working with the same data, and I was going to create the same kind of graph. We're creating TS diagrams from that glider. So I imported here GeoViews and the HV plot for pandas. And no, something is definitely wrong with my computer. It's not showing even the map. So this is another declarative way of plotting, right? You're declaring the kind of plot, which is a scatter plot, very similar to Altair. We declare the axis, X and Y. These options here are kind of similar to matplotlib. So it's a mix of declarative and imperative. The main difference are these two here. Has anyone ever seen this in any graphing library before and know what they mean? So rasterize, when you have a lot of data and the plot is really slow and you want to make it faster, you can rasterize your data. So it's going to become like just pixels. It's very useful when you have like many points or many different lines. But you don't do this if your plot is simple, because it also degrades the quality. Data shade is another option that's very interesting. Data shade is great when you have a huge amount of data and you still want to zoom in and out and update the rasterization. So if you rasterize something, when you zoom in, you should get blown up pixels, right? If you use data shade, it will recompute and will give you a new image. Just so you see the difference, this is the plot with all those options. So we have all the points, and you notice how slow it is, and it's slow to interact with it. Like I'm dragging here. See how long does it take to drag, or even the hover tool. Now with those two options, it's blazing fast. Like it's because I have a lot of points in there. So another way to interact with HVplot is, well, these are all pandas objects, by the way. This is a data frame. This is also a data frame. You could create this plot by hand yourself using Bokeh. Bokeh is this software with this symbol right here. Just don't do it. Bokeh is like MATLAB, it's imperative. It will take you about 50 lines of code to create this graph. Oops, sorry. 50 lines of code to create this graph with Bokeh. So you can have that for free if you use the HVplot interface.
The data shade is it, in my understanding, it's almost showing sort of like a PDF of where the data is, like it's showing where it's more dense.
Yes.
So if you were actually to try and explain this figure to someone, it would probably be like a PDF. It's not a combination of a PDF and
PDF in the sense of
well, just that it's showing the density.
the density. Yes, you're right. Like this is more dense, more points, and this is more sparse. If we don't data shade, we don't really know that. We can't really see where the points are. Oh, that's new. Right?
Yeah, so this is what most of my plots look like.
Like I have no idea if this is dense and this is sparse.
Really, it's the data shade sort of, it just shows you where the points are more dense.
Yeah.
Similar to a probability density function.
Yeah.
Yeah.
Correct. So a simpler graph that we don't really need to rasterize or data shade, right? So same thing, I'm just declaring the axis here. What's X, what's Y. And the only pet peeve that I have with this stack is on matplotlib, we declare the height and the width in pixel points. And here is, no, sorry, matplotlib is inches and here is pixels. So it doesn't translate well if you're importing one image to the other. So this is a CDD cast using HVplot that uses Bokeh underneath, that has a JavaScript backend that gives you this nice interactive graph on Jupyter Notebook with all these tools, like the hover tools, zoom in and out using the wheel and all that.
You can't like export that like this.
You can export as an HTML if you're creating a page. You can export as an image.
So you no longer need to change Bokeh to get that in your HTML.
The tricky part is this, and I was getting there. If you have a live kernel and if your figure is touching the data back and forth to show extra computation, then you need a live kernel, and there is a service for that that's called Bokeh server. If your figure is done, pretty much people are only going to zoom in and out and pan, the HTML works just fine. Okay. Oops, sorry. Are you following me? Can I move along or? Okay, so just for fun, I made the same figure in Matplotlib here, right? We don't really have those options of rasterizations or anything, and it's not interactive. This is like a PNG. If I change the backend, I actually have some interactions. I can do that, but they're not fast and snappy like the JavaScript backend. The message here is, if I'm creating a tool to explore data, go for this kind of libraries. If I'm creating a plot for a publication, go for Matplotlib. So now we're gonna play with HVplot interface again, but instead of using that on pandas, we're gonna use that with Xarray, because Xarray also have a backend for plotting that. So we're loading this data here from a Fred server. By the way, who here was actually able to run this? Good. All right. Only the Altair port that didn't work. Yeah, I'll fix that in the afternoon. So just so you understand how big this data is, it's about like 5 gigabytes of data. Only the surface, right? Only this slice of surface. So what I did here, I called the plot function in Xarray. It gave me this nice cartopy plot, but I find it kind of ugly. And I really want a hover tool because I want to know the temperature on those points. So I do pretty much the same command, just with some extra options, but calling HVplot instead. And the beauty of this is now it's part of the HoloView stack. So I can add stuff to the plot from the HoloView stack. So I can add, for example, like a feature, and they have this length feature that, by the way, Shell would help you with that problem. And now I have this nice interactive plot where I can actually hover, see the latitude, longitude, and the temperature. I can zoom in, and as you can see, it recomputes. There is a limit, of course. Now I'm pretty much on the grid cell limit. You can reset it here. If the hover tool is annoying you, you can turn it off. And the beauty of this is I got for free a slider, so I can evolve this in time. This is the moment where everybody goes, ah. And everything is lazily evaluated. Like I'm now loading the time frame, the next time frame, only when I move the slider.
So like if you were to do this with an Xarray object, you would have to read it from Xarray to pandas and then.
Yeah, this is an Xarray object, right? Like both Xarray and pandas have the HVplot interface. The only thing that you need to do to start them is to import it. This is actually a bad Python practice because we're importing this, but we're not calling anything from that model. It just enabled us to do this. If you're a die-hard Python programmer, you don't like that. But because we're scientists who program, we don't really care. Any questions? No, it takes a while because it's downloading that size on the fly. Like for me, it's relatively fast. Oops. It's relatively fast here. Like just move it here. Let's give it a few seconds and it should refresh automatically. Yeah. See? It's not refreshing for you? Yeah. Maybe the connection is not that good today. You can pre-download some of those frames if you're going to serve that on a web page. Sorry, question? Yes, you can to fix it as you move along with the other frames. You can do that. It's possible. Like you pretty much need to do a C lim min and C max, and then the color bar will be frozen. Usually when you're doing interactive stuff, you really want to do that. You want to do that when you're doing publication level stuff. Right. So a third package that I want to demonstrate here is the Seabourn package. Some people actually don't care about this kind of packages because if you're physical oceanographer, you don't really care. But if you're biological or chemical, you do a lot of statistics like plots. And Seabourn is probably the best one out there to do it. Tries to mimic some of the R-word ggplot kind of thing. And it's highly customizable. You can pretty much create a dictionary with all your own customizations. Here I'm gonna load some data on pandas. We have a data frame. And if you compute the correlation, the cross correlation using a pandas function, you can then do a Seabourn heat map with it. And you can have like this really beautiful statistic, like descriptive statistics kind of plot. And you can explore the data very easily. Like instead of looking at the table, I can come here and see that for this animal, like weight is related to size. Amazing, right? The bigger you are, the heavier you are. But jokes aside, it actually helps you explore a data set very quickly. And it has some methods to do joint plots. So it did the regression for you between those two variables, and then put the distribution here so you can explore what's going on. In this case, it was very helpful for them to easily identify that they actually need to average the individual animals collected every day to have a meaningful regression. All right, who here actually thinks Seabourn may be used for them? They have a great gallery, great documentation. Go for it. Like I said, this is kind of just an overview of these topics. I'm not really going to teach you how to use Seabourn. Okay, just want to make sure that you know it exists. Let's go to the next notebook. Yes?
My biggest concern with Seabourn when I tried to use it was that it didn't calculate all the statistics, so I had to do that.
Yes. For example, when you do a regression, in the past, it used to give you all the statistics. They decide to not do that anymore. The reason is they want to be a plotting library and not a statistics library. So you have to use that in tandem with statsplots or scikit-learn or some other library. And it was a sane decision, in my opinion, mostly because if you're doing a statistics library, you're responsible for that result. And if you have better packages upstream that are well maintained, why you're going to reproduce the same work, right? Okay. So the next notebook is the EarthSync stack. The EarthSync stack is actually pretty much the same thing as the HoloViz stack with some extra methods and options for us to explore this kind of data. So I'm pretty much loading GeoViews, HoloViews, and CartoPy here. And I'm using the OpenStreetMap styles. And I'm going to create a map using the tiling service. And this allows us for some extra interactivity. For example, here, let's see, if I click on this new hover tool here, I can add points to my map. And I can hover over the points to get the latitude and longitude. Let me exit slide mode for a second to make this easier. I lost the hover tool. Yeah. And if I'm doing this on a live kernel, I can go back here. Let me run this so we can have run all both. Okay. Now, if I add some extra points here, I can get them back on Python, right? So it makes for a great tool for 2D interactions, like two-way interactions. I can add points and I can get the data points put back on a frame. I actually use this to plan scientific cruises, for example. And you can move the points, you can delete them, whatever. There are also more advanced tools where I can create some fixed shape polygons. I can move them, I can create new ones. And same thing, I can get them back. Like I moved it, so now I have a new one. We can do lines. Oops. This one has a bug, like the polygon and the line and the drawing have the same icon, so you have to hover over them to know which one you're actually using. And the same thing, you can also get that object back. Who here think this is useful for them in their daily work? Great. Two hands? That's how excited you are about this? So if you're excited about this, I'm actually going to show a real life example of something that you can do. And the image is tiny for some reason, but it should not. So I open a shape file for a model that has this grid here on this river. And because I'm not from here, I have no idea what river is this. Can some local person help us? Columbia River, yes. And I'm trying to zoom in and zoom more. And as you can see, let's suppose this is not right, right? There's no water there. We don't want our model grid to go there. So we can edit our shapefile. Unfortunately, there's a lot of points, so I'm not going to do all those, but you can go there and fix your grid or your shapefile by hand. Here, the ideal thing to do would be to remove some of those points and have less points, but you can fix your grid and then you can get that grid back. So if you're a numerical modeler dealing with regions where you don't really have the data to construct your grid, someone was talking about salt marsh yesterday. Like you have to go to an image to actually get the right contour. You can do this using this kind of tool. Okay. Who here learned something new? Awesome. That's what we're here for. So there is a huge tutorial here on this link. Follow it later. Yeah, you have to click here, and then you double click on the actual shape. It's not as responsive as it should. Like the JavaScript is kind of slow there. Sometimes it takes a while for it to respond. Okay. So I'm going to go to the next notebook. So in the EarthView stack, we actually were plotting all our data on top of styles that we call sleepy maps. Everybody here is pretty much used to sleepy map on their phone, right? Every time you Google Maps something or Apple Maps or whatever, you have those pinch movements. You can zoom in and out and all that. What if you want to plot your data on sleep maps? You can use the EarthView stack, but they're kind of limited to that squared shape. It's not very, how can I say, it's not the same thing that you use to your phone. So if you want a closer experience with what you have on your phone, there are these two libraries, one called Folium and the other one called IPyLeaflet, that pretty much will give you very snappy, very fast sleep map, and you can plot icons. This is actually wrong, we're not there. I think I used the eScience latitude and longitude. We're actually older. By the way, here's an exercise. Find the latitude and longitude of Alder and change that. With Folium, it's pretty easy for you to add a marker, add a pop-up. We have many plugins. We have a drawing plugin that will give you a similar functionality to what the EarthSim have, without, unfortunately, the two-way communication. To get that object back in Pandas will take you a while. It's possible, but it's not that easy. You have to save a file and load the file again. We can do some exercises if we're up to it. You can, yes.
Is there a way to get it out?
Yes, there is. That's actually a great question. So I saved it as an HTML. As you can see, the HTML is here, right? I'm gonna start a local server with Python. There you go. So if you actually have your own server and you want to serve a map there, it's relatively easy. And if you know some Flask, you can create some very nice integration for us. So you can query some data and plot the data on top of them. Okay, I'm actually gonna pass the exercise. If we have time at the end, we go back to them. Folio has many different tiles. And here, I'm gonna compose a map that actually may be useful for some of you. So I'm starting with this CartoDB positron tile because it's a dark shape one, so it's easier to put data on top and see the data. But as you can see, the OpenStreetMap was one is kind of colorful. Oops, I need to put the object back here. If I'm gonna plot data on top of this, it can get confusing. And now I'm gonna read two JSON files, GeoJSON files. Who heard about GeoJSON before? Okay, just a few people. So GeoJSON files, they are the standard way of having shapes, points, lines, and polygons on the web. They're similar to the JSON file, which is the data streaming for the web, but they know about the geography. So I'm loading two GeoJSON files, and I'm gonna plot them on top of my map. And now, let me go out of the slide mode so you can actually see the map. With just this loop on the GeoJSON, I was able to create this map. And this is actually one of our regional associations with all the HF radar regions here, the buoys, if they're active or not, and the stations, right? So if you're a data manager for a certain regional association, you want to create a map like that, it's relatively easy. So check out the Folio gallery. We have a lot of examples in there. I'm not saying this enough. All these tools, they have galleries and tutorials. Don't go for the tutorial first, go for the gallery first. See something that you want to do that's similar and start modifying and then go back to the tutorial. Why I say that? Tutorials can be boring and can put you off, right? Start with the very basics, and until you get to something that's useful, you give up the tool. If you start with something that you want to plot and you can reproduce that plot, you feel excited, and then use that excitement to go to the tutorial and do it. All right. So there is this extra package that I'm going to show here very briefly that deals with numerical model grids. So I'm going to load the grid from a Fred server. And this is one of those very complex mesh grids. It's a finite element one. I'm going to trace the outline for that grid. If you're running this for the first time, it may take a while because it's getting all those data points and tracing the outline. I already run it, so I have it here for me. This is how the first 10 points of the grid actually looks like. We can't really display everything. That's why we're doing the outline only. And I can rasterize that manually to create a matplotlib figure. So here's all the elements. If you're using the Holovis stack, this rasterization would come for free. You don't have to do that yourself. And I can also plot that on a Folio map. And here it is. It's the same model, the same Columbia River that we used before. So if you have a bunch of numerical models and you want to show your grids on a Sleepy map to show what you're doing, it's relatively easy with that package. Okay, any questions before I go to the next one? Is it too fast, too slow, a lot of information that you don't really care? You're not to all of those. Yeah. Okay. So a similar package to follow is IPyLeaflet. The main advantage is IPyLeaflet works as a Jupyter widget and has this two-way communication with Python. The main disadvantage is it's newer, has less feature, and requires more code to do the same kind of math. The message here is, I'm biased towards volume because I'm the author, but the future is IPyLeaflet as it gets better and it's improved. So the syntax is actually very similar. Like we declare tile, we declare a center, we declare a starting zoom, and we're gonna change the zoom later. And here I'm gonna do something very cool. I'm gonna load this wind data from an etcdf file. I'm gonna just fill up some of the visualization options. And we're gonna load that wind data with Xarray, and we're gonna add that to a layer, and it didn't run because of the JavaScript. And here's the problem of IPyLeaflet. Let me just run this very quickly. What? Let's see. That is not fine. No, let's do it the old way. Should be here. Okay. There you go. This is another moment. So this data is actually not animated. Okay, it's a plugin that gets the static data and does the streamline, trying to get the tendency where the vectors would go. You've probably seen this before. It's a JavaScript plugin. And the power of these new libraries is this. You can pretty much get all these new cool web visualizations and have them easily and wrapped in a more sane way on your Colobis, Earthsyn, or Volume and IPyLeaflet. Sure. Yes, it's one-time step. It's not really an evolution in time. It's just when you plot the vectors, it creates streamlines and it creates an animation where it should go next.
Okay, so could I do this with multiple time steps? You would actually do this.
With this plugin, no, but I'm pretty sure there are plugins to do that. I don't know one on the top of my head, I'm pretty sure there are. People probably did this before. So last but not least, we can use pretty much any tile behind our map. So we use OpenStreetMap, we use this CartoDB with kind of dark one and good plot things on top. And here, I'm using one that's not even on Earth. Does anyone know where this is? It's Mars. Who said that? You get an extra sticker. And you get even another sticker if you know what this data is, what this data are. So this is actually point-by-point description of where the guy from the Martian book was. It's Matt Damon. You can follow Matt Damon on I Sleep Map on Mars. The book is better. All right, so are we good with sleep maps? I have an actual exercise before we go. Let me see if we have time. We do have time. I want you to go up to our first cell, and I want you to create your own folio map by modifying the center, modifying the tile, and adding just one marker with one data point somewhere. And I'm gonna give you about 5 minutes to do that. And if I see a lot of blue stickers, I'll just move ahead. If we see orange stickers, I'll go around trying to solve the problem. Not easily, no. Can you answer that? Well, I actually want you to play with this. I want you to create a map on a different position with a different zoom level and add your own mark. Just so you feel that you can do it. Like if I'm only demonstrating and you're only running cells, we can disconnect from the process where we actually know that this is easy and you can do whatever you want. I'm actually gonna add some extra stuff here. By the way, I don't know if you noticed, most of these sleep maps are lat long and not long lat because they are created by JavaScript people and they went with alphabetical order instead of geographical order. Be aware. By the way, that's why I usually name my variables and then I put them here. So I remember that. If I just put numbers here, you had no idea, right? That was lat long. This is clean code and good practice that we always try to imprint on you while we're teaching something else. I'm gonna paste this on Slack. It will help you to find different tiles. Okay, so I post something on Slack that will help you find different tiles. And at the end of it, you're gonna find even more tiles, right? So pretty much everything in here you can use. So, okay, our 5 minutes are up. I don't see any audio stickers. That's awesome. You guys, oh, there's one. No helpers? Okay, I'll go there. Hopefully that phone is going right. Okay, are we good to move ahead? So if your project requires a map, and if you want to present a really nice web interface for people to navigate whatever you're gonna show, you have two good options. The next notebook is kind of a tour on the geospatial stack. So it's not really ocean stuff, but every now and then we need to deal with geospatial data, right? Who here has to do that on a day-to-day basis? Only one, or not? 2, 3? Who here has to deal with geospatial data? Shape files, images, raster files. If you're using satellite imagery, you are using geospatial data, right? So there are these two libraries, actually 3, GeoPandas, Shapely, and Rasterizer, which will make your life way, way easier. By the way, if your image is big, Xarray has an interface for Rasterizer. So you can actually open your Rasterizer object inside Xarray and have all those nice things that Joe showed us, just scale up. Okay, so we're gonna load some data. And the first one is GeoPandas. As the name says, it's pandas, but for geographical data. So every column of data has a geometry value. GeoPanda has its own plotting functions. This one is actually a matplotlib plot, but we can explore that geometry object a little bit more. So if we do countries, and I'm just gonna get the first object there. ILOC. Zero. So this is the first one. It's in alphabetical order, so it's Afghanistan. And if I get the geometry here, we have the actual shapefile for that country. And Jupyter here is doing something really nice for us. Jupyter has very different repos to represent the data. Jupyter knows about shapefiles, and instead of showing us data, it actually shows us the shape. But we can access the data because this is, at the end of the day, just a shapely object, which the second library that I was going to talk about. That's a shapely object. And we can manipulate shape with it. And someone actually asked me, can I get the values from a shapely object? I think it was you, right? Yes, you can. Like there are many methods here. So this could be a coastline or something similar. And okay, if you try to get a boundary, for example. Boundary. And here we should have, this is now a line string, and here we should have a way of getting the X and Y. Just don't remember on top of my head. X, Y, actually, we get them both. There you go. That's the array. And that's what you want if you're exporting this to somewhere else, or if you're using this as a contour for a model or something. Okay. So I kind of went ahead and I did part of the exercise. This is the second data set that I loaded. It's rivers. And thanks to Shapely, we can do high-level queries. Like, for example, I just sliced in a way that pandas understand. Like, I want all the rivers that have the Amazon name on it. and I squeeze the shape out of it, and now I have a line string with the actual Amazon River X and Y points. That was easy, right? Because we all know pandas really well, so we all know how to slice things with pandas. If you had to actually look over the shape files to do this, it would be 10 lines of code easily. And here I did it one. And we can do some things. For example, there are some geospatial operations. What countries does the Amazon River crosses? So we do countries.crosses that object. Voila, 3 countries: Brazil, Colombia, and Peru. Okay, there's this high-level interactions with this kind of objects. And here I'm mixing GeoPandas and Shapely, because at the end of the day, GeoPandas are Shapely objects on a pandas data frame. There are many other operations. I'm not going to go over all of them. Just look at documentation. And some people are laughing because they probably already noticed that this exercise is actually, there is a gotcha in the end. So how many countries have border with Brazil? And most people don't know this. Brazil has a border with France. We just don't get to go to Paris because it's this France here, your territory, French Guiana. So the next one is Raster.io. We're all dealing with vector data at this point. So Raster.io deals with raster data. I'm gonna load this image of the whole globe just to show you what Raster.io gives you. It's lazily loaded, so it didn't really load anything. It's just a dataset reader object. I can request the bands for that image here. So the red, green, and blue bands. I can plot histograms. Probably only Shell is the one that knows why we have to do this. Everybody just have the final image here. But usually you need the image histograms to fix and fine tune depending on the feature that you want to highlight. It has all the metadata from the geotiff, position, the type of data, the shapes, the CRS, the coordinate reference system. But what is best about it, like I'm gonna get only the red band, just one of those bands, is that I can reproject and put that on a Cartopy image. So I have this square pixel thing that I plot on Cartopy, and because I know about the projection, I can use any other form. So I actually went for the interrupt geomode formal sign, which is probably the most exotic one that I can think of. And I have my raster image properly displayed in there. Who thinks this is cool? Awesome. We have some map fans here. I'm not going to talk about these other 2 libraries. I'm just going to mention them. And I will know your age as soon as you answer this question. Who here heard about GMT? Yeah, you're either old or interact with old people. GMT is awesome. It's probably one of the best mapping tools out there, but it's really, really old and hard to use. They actually have a Python interface now, which is coming up really nicely. Check it out. It's in early stages, so we are looking for feedback. And the other one is Geoplot. Geoplot tries to be what HoloViz is for this whole visualization stack, but for the Geo stack. It kind of wraps Cartopy, GeoPandas, and all that in a higher level way of plotting things. They're both worth checking out. I personally don't use them mostly because Cartopy is easier for me. However, if you're a die-hard GMT fan, you're probably going to be pleased with that project. Yes. No, actually, I was very surprised because when I met with the authors of that library, they have a GMT meeting that apparently has 600 attendees every year. I don't think it's going to die out. I think some communities abandon it because other tools showed up. The oceanographic community kind of abandoned it. The geophysicists never abandoned it. They're definitely die-hard GMT users. And it's great. It's just really, really hard to interface with GhostScript to create your plot. Like, you need a whole day course to get people to do a very simple thing. Like everybody here did the polygon plot, right? We'll still be solving our direct or double redirects if we're trying to do a geometry plot. Orange stickers everywhere. Any other question? So I have 10 minutes. We can either do exercise or I can show you some of the extras. Actually, this one is completely empty. I actually want you to play with this data set. It's the hurricane data set from Kaggle. Who here heard about Kaggle before? Okay, it's, I don't know if they're a company, I think they are. They have these data science competitions where they have these data sets that you can play with. And if you come up with something cool, there are prizes. So they have this both Pacific and Atlantic data sets for hurricanes. It's a historical data. And on this notebook, I only parse the data and I load it for you. I actually want you to explore it by creating plots with all these libraries or some of those libraries, whatever makes sense for you. Oops, file not found. Oh, I have to push the file, sorry. So I'm gonna push the file and I want to play with that. If it makes sense, even incorporate that in your project. Is anyone working with hurricanes? True, okay. So as soon as I push the file, I want you to play with that. I actually want to give you a structured exercise, but I find that's for plotting, it's usually annoying. I can't really do a structured exercise because you all have different interests. I can give you a glider track. Someone is going to be interested in the profiles, others are going to be interested in the TS, others going to want to plot a section, others are only interested about the track. So I actually want this to be free form. Do whatever you want. If you hit problems, find me later. All right? And just a very quick tour on the power of the plugins that you can add to Folium and IPy leaflets. Oops. You can very easily load data from, mix and match data from JSON and pandas to create color plots like this. And they are kind of interactive and have a color bar. You can do drawings. These are very responsive. This is better than the everything in the point, in the sense that they're more responsive. This is worse than HoloSims in the sense that you need to click this export button to save the file and load it back on Python. Like the two-way communication is not good here. The reason is we went for fully wrapping the JavaScript. So this can be a standalone map later. IPy leaflet went to be a full Jupyter widget, which requires you to actually npm install your Java libraries locally for it to work. It's a trade-off between portability versus two-way communication with Jupyter. For a moment there, we almost went the same model as IPy leaflet, and we decided that if we do that, then these two libraries are going to be completely redundant, and we don't really need them. So we decided to keep it this way. So we actually have different options depending on what you're doing. And this is probably one of my favorites. You can plot WMS servers direct on your map. And here you can explore the WMS services using OWSLib. You'll probably remember that you use OWSLib FES to create our OGC filter, the Open Geospatial Consortium. And because this also follows the rules of the Open Geospatial Consortium, we can put a URL in there and find all the relevant information automatically about that server. They have a WMS response, and we can just put it here. And again, it's a timed WMS, so we can change the time slider here and get the sea surface temperature from another point in time that exists on that server. It is slow though. It's quite slow actually, because it's fetching the data on the fly. But the zoom response is relatively fast. You can do videos. And it's not playing. So if you have a georeference video, which for some reason is no longer playing, you can actually put it on top of the map and it will play for you. You can have multiple types of pop-ups. Your pop-up can be a graph, can be a pandas table, can be text. It can be pretty much anything that you can wrap as HTML. You remember from my hurricane example, I actually wrapped a bokeh plot. So when we clicked, we had the wind and the sea surface heights plot. It can be a raster plot as well. It doesn't have to be interactive. You can do linked map, exploring two different sets on the same area. You can do all sorts of shapes, lines, circles, and etc. And here, it's probably the one that I like the most because it mixes everything up. I'm loading the continents, the country data again and the river data again in GeoPandas. I'm filtering for all the rivers in South America only using those pandas operation. As you can see, Unicode is still not there yet. Some of the rivers are misnamed. So I create a dictionary to fix those names. I filter them, and I'm plotting them using this line string object and using a plugin that's called antipath, like where the ants are going. So I can actually have the line strings with the direction of the flow of the river in a slip map. Again, this is an aha moment. All right, so we have 4 minutes to spare before we break up for lunch. The only exercise here is explore the data set, create your own plots. If you're proud of your plot, give a lightning talk on it. If you find problems, come find me. And if you want to do something different with a different data set, that's fair game as well. But try to use at least one interactive tool and one declarative tool. Altera unfortunately didn't work, so we're pretty much stuck with htplot or I'm gonna try to fix it though, or Seabourn. Any questions? Nope. You've been a great audience. This was my last tutorial. I'll be here the whole week though. Thank you so much.